takes before it even sees a refinery? I mean, it's a story that kicks off millions of years ago deep inside the Earth, and it involves crazy amounts of pressure, ancient life, and some seriously clever engineering. All right, let's jump right in and follow this journey, from how petroleum is born to its very first cleanup.
Okay, first things first, let's bust a huge myth right out of the gate. When you picture where oil comes from, what do you see? Is it these giant underground lakes or rivers of black gold? It's a super common image, but the reality? It's way more interesting and, honestly, a lot cooler.
To really get what petroleum is, we've got to rewind the clock. And I mean way, way back. We're talking millions of years ago, to a time when ancient seas and swamps pretty much covered the planet. This is where the whole story of oil and gas really begins.
So the most widely accepted theory, the organic theory, says it all started with teeny tiny plants and animals. When they died, they just sank to the bottom of these ancient oceans. Then, over millions of years, layers and layers of sand and mud piled on top. All that weight from the rock plus the intense heat from the Earth's core basically just cooked all that organic stuff, transforming it into the hydrocarbons we call oil and natural gas today.
And when you boil it all down, that's all petroleum really is. It's a hydrocarbon. Molecules made of just two things, hydrogen and carbon. That's it. And the way those atoms are arranged determines if you get a gas, a liquid, or even a solid, like asphalt.
So, this oil and gas gets created deep underground. But if it's not in these big pools, where is it? Well, it turns out it's actually trapped inside a prison made of solid rock.
That's right, the oil and gas aren't just sloshing around in some underground cave, they're held inside the rock itself. Which probably makes you wonder, wait, how can solid rock hold a liquid? Well, it all comes down to two really important properties of that rock.
First up, the rock has to be porous. Now, porosity is just a fancy word for the amount of empty space inside a rock. The best way to think about it is like a giant, super hard sponge filled with millions of tiny, microscopic holes. Those little holes, or pores, are the storage tanks for the oil and gas.
But, just having storage space isn't enough. The rock also has to be permeable, and permeability is all about how well those tiny little pores are connected to each other. See, if the pores aren't connected, the oil is stuck forever. But if they are connected, they create a pathway, and that allows the fluids to actually flow through the rock.
Okay, so we've got oil and gas, trapped deep underground in a rock that's both porous and permeable. The only thing missing is a way for it to get out of its rocky prison. And that's where we humans and some absolutely massive machinery enter the picture.
For all their incredible complexity, the basic job of a drilling rig is actually really simple. It's just to punch a long, continuous hole, a well, all the way from us up here on the surface, down thousands of feet to that pressurized rock formation. It's the escape route we build for the oil. So, once that pathway is open, the natural pressure down in the formation does the work, pushing everything up to the surface. But the stuff that comes shooting out of that pipe, it is not the clean, ready-to-use crude oil you might be thinking of. Oh no, it is a complete and utter mess. In the industry, they call it a multi-phase fluid stream, which is a much better description because it's a mix of everything that was down there in the rock. You've got your crude oil, sure, but you also have natural gas, a whole lot of water, usually super salty water, and even solids like sand and silt. And in the oil field, there's a great acronym for all this unwanted junk, BS&W. It stands for Basic Sediment and Water. The number one goal of this first treatment phase is to get the BS&W out of the oil.
The problem is, separating this stuff is really tricky because the oil and water form something called an emulsion. The perfect analogy for this is salad dressing. You shake it up and all those tiny droplets of vinegar get suspended in the oil. It's the exact same thing with crude. Tiny water droplets get trapped in the oil, and they are incredibly stubborn about separating on their own.
So that brings us to the final leg of our journey today, the first cleanup that happens right there at the well site. How in the world do you take that messy, emulsified stream and turn it into something a pipeline or a refinery will actually pay for? The mission is pretty straightforward. You have to break that stream down into its three main parts. You want clean oil going one way, clean gas going another, and water that you can handle properly. And this whole separation dance happens in a series of big, specialized steel vessels. The first stop for our messy mix is usually a tank called a free water knockout, or FWKO.
And it does exactly what the name says. It knocks out the free water. That's the water that isn't mixed in too tightly and will separate from the oil just by letting it sit for a while and letting gravity do its thing. It's basically picking the low-hanging fruit of water separation.
And why go through all this trouble? Well, because water is a huge problem. It causes pipelines to rust from the inside out, which is a disaster. Plus, refineries have super strict limits on how much BS&W they'll take. If your oil is too wet, they'll just say, nope, we're not buying it. So getting that water out isn't just a technical step, it's an absolute economic necessity.
Now, for all that water that's stubbornly stuck in the emulsion, gravity just isn't going to cut it. You need to give it an extra push. And that is the job of the heater treater. This piece of equipment brings heat into the equation to finally break apart those really tough emulsions.
The process is actually pretty clever. The emulsion flows into the vessel and gets heated up by fire tubes. This heat gives those tiny water droplets more energy, which makes them zip around, collide, and merge into bigger, heavier drops. That process is called coalescing. And once the water drops get big and heavy enough, gravity can finally take over. They fall to the bottom, leaving cleaner, drier oil to flow out from the top. So, there you have it. From microscopic life, to a rocky prison, to a messy mix, and finally, to the first big cleanup. That's the initial journey of petroleum. The crude oil is now finally clean enough to be sold and sent on its way. But this is just the beginning of another, even more complex story. What exactly happens to it at the refinery to turn it into all the fuels and products we rely on every single day? Well, that's a journey for another time.